Okay, this is a Unit 8 practice test review that I'm going to be doing. All right, so for the first thing that you're going to do is you're going to put all this information into your calculator. So to do so, get your calculator out. Let me get mine. Open up a spreadsheet. And I'm going to go ahead and label it. I'm just going to label it day. It doesn't matter what you label it, just has to be labeled to something. All right, so I'm just going to put all the data in. And you're going to put it all in one column. I know on the worksheet itself, it's in several columns, but that's just for space on the worksheet. Nine 9.3, 5.1, 7.5, 11.4, 10.1, 6.5, 8.8, 4.6, 13.6, 9.5, 15.9, 4.9, 10.1, 12.8, 7.1, 7.4, 8.1, and 10.2. Excellent. Okay, so let's go back here. And the first thing it says to do is to make a histogram. So to make a histogram, we're going to do this. You're going to go ahead to add a data instead spreadsheet, and you're going to hit day. Now it gives you a dot plot, and you're going to go to menu, plot type, histogram. And if you don't like the bins, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, about 13 bins. So the bins are a little wide. You're welcome to do it like this because it's not like ridiculous. But if you have 20 or 30 bins, you're going to want to change the width. So I'm just going to show you how to change the width. So you hit menu, plot properties, histogram properties, bin settings, equal bin width, and it's going to give you what's currently. Currently mine's at 1. Alignment is 3.6. That means that's where it's starting here on the x-axis. If you notice, the x-axis starts there where a little bit below 4. That's about 3.6. So that's fine. If I wanted to change it though to 2 or maybe 1.5 or something like that, because it's not super big. If I had 30 bins and I wanted 15 bins, I would double it. So I have about 14 bins, so I'm going to make it a little bit bigger. And then if I can't see it quite right, actually mine I can see pretty well, but I can't see this one here to see how high it is. So I might go menu, window zoom, and then with zoom data. And there's my histogram. And so what I'm looking for on my histogram, I'm going to make sure that you remember title, label, tick, tick, tick. So you're going to put the title. So let me go ahead and bring it over here. So how I would look at, sorry. So here's the answer here. And this one looks a little different than the one that I just showed you because the bins this is by 2. So if I change the bins to 2, you'll see that it's going to change again. Plot properties, histogram properties, bin settings, equal bin width, and you'll see this one looks like it's at 2, the one that's on my picture. So that changes it just a little bit. It might be a little bit above 2 actually now, but this is about what it's going to be. Anyway, just make sure that you have a title, you have a label, oranges, weights, and ounces, the frequency on the left, and make sure all your numbers are here. All right, so for the next one, it asks to discuss the conditions. The conditions that I'm requiring for you to do, I see that there's a bunch of conditions, is the random condition and the normal condition. Those are the 2 that we've been doing. So random condition is that, yes, they were randomly obtained because that's what it says right here. And then the normal condition is that, remember, because this is a means, these are averages, n greater than or equal to 30 would imply that it is approximately normal. However, n, which is the number of samples, is 25. That means there's 25 pieces of data here. And since that's less than 30, I have to draw a picture. But the picture, as you can see, is approximately normal. So we're okay. So this is the deal. If n is greater than 30, it guarantees that I've got a normal model and I don't have to check it. But if it's less than 30, then I have to check it, and so that's why we checked it. Okay, so the 95% confidence interval, let's go ahead and do that. Now, I need this here. We know that for my standard error, I have s over square root of n, and I need that. However, I don't know what s is, and I don't know what square root of n is, or excuse me, I don't know what n, or I do know what n is, excuse me, it's 25, but I don't know what s is. So the way I'm gonna have to do that is go back to my spreadsheet. So go back to your spreadsheet, to your data, and we're gonna do what's called menu 411. So I'm gonna write it down here for you. You're gonna write menu 411, okay. And then you're going to use a drop-down menu on the X. And then you're gonna hit okay. All right, so I'm gonna go ahead and do that for you. So menu 4, mine isn't labeled because it's on my iPad. So 4 is statistics, 1 is stat calc, 1 is one variable, and then we're gonna hit okay because I have one list. And then here's my drop-down menu I called day, and I'm gonna hit okay. And we're gonna go up here and you're gonna see there's all your data you're looking for. So X bar is your mean, S is your standard deviation, and your S is 2.8789. So here we go. So now you can see where all these are coming from. So make sure you understand that standard error is S over square root of n. Margin of error is my T star times S over square root of n. And then we're gonna talk about the T star. So let's look at T star 24. The reason it's 24 is because the degrees of freedom is n minus 1. My n is 25. So you're going to go to inverse T, and the area is going to be my confidence level plus 5 plus that tail. So my confidence level is here at 0.95, 95%, but remember there's a 0.025 on this side. And the area that I want is I want this location here, so I have to kind of trick the calculator and say, I want this value right here. But in order to get that value, I have to go past the 0.025 and past the 0.95. It's shifted, so that's why I'm going to put 0.975. And then, of course, it asks for the degrees of freedom, and you put 24 for that. All right, so after that, you are going to go ahead and do the confidence interval. So remember, the confidence interval, here is the formula here. It says Y bar. It doesn't matter if you use Y bar or X bar. It doesn't matter. The way you've seen it is X bar, which is the mean, plus or minus T star, and then times my standard error. And here's your standard error, S over square root of n. And then, of course, which is, this is S over square root of n. Okay? And then to get this, the way I'm going to get this number and this number is I have 9.484 plus this number, which was, my margin of error was this, the 1.185. And 9 minus 9.484 minus 1.885. All right, because this here, how did I get that? This here is right here. And so this is 1.1885. So it's getting 9.484 plus or minus 1.185. All right, and to evaluate it, I am 95% confident that the mean weight of oranges from the sunny day orchards, so I'm just kind of copying everything that the question asked, is between 8.2 and 10.62 ounces. Make sure that you use the context. All right, let's move on now to the next part. The next part is asking, it says, forest rangers believe that 20% of the trees, so that's going to be my P hat, and I'm going to have, this is going to be my n. The first one that we did, all of this here, this was all means. These are averages. Notice this is weight and averages, and it's called quantitative data. Now, this one here that we're doing is proportion. It's talking about percentages. So this has a different formula. So the formula here that we're going to be doing is p hat plus or minus z star p hat 1 minus p hat over n. This is the confidence interval. The confidence interval for the one we just did was x bar plus or minus t star, s over square root of n. This is when I'm talking about means and averages. So when the problem asks what the average weight is or thing like that, I use the blue one. When it's talking about proportions or percentages, I use this one. So this is with categorical data. With categorical data, I can put it in categories. Yes, no. What's your favorite color? With quantitative data is like saying, what's your average weight? What's your average age? All of those type of things. So it's the same. We're doing really the same thing. We're just, the question is a little bit different. And so then we're answering a little bit different question. And therefore, we have a little bit different formula. But everything else is similar. Now, for normal model for this one, we're going to be using n p hat, which is what? 120 times 0.2. Has to be greater than or equal to 10. And then n 1 minus p hat equals 120 times 1 minus 0.2. And that has to be greater than or equal to 10. Recall, when it was quantitative with the means, what did we do? We did n bigger than 30. Because I don't have a proportion. I just have a sample size. So when it's means, I have to use n bigger than 30. When it's proportion, I have to use n p hat and n 1 minus p hat bigger than 10. And again, if they're not, then we draw it. And we draw it and we look and see, oh, well, the model looks pretty normal. Because these are what's guaranteeing the model to be normal. But if it doesn't meet the requirement, then we just view the graph. And if it is, then we're okay. And the second one we're doing is a random sample. Now, this does not state that it's a random sample. And if it does not state it's a random sample, you must say, okay, because notice it doesn't say anything about a random sample anywhere. So the whole idea of a random sample is that I have a good representation of the population. And so you can say, well, it's not stated, but it looks like it's reasonable to assume that the rangers are going to get a good representation of the population because they want to take care of the forest. They want to do what's right for it. All right, so this one here I told you is a bonus question on your test. So it says, what proportion of infected trees on this sample would lead you to believe that the true proportion of infected trees is higher than the rangers believe? Now, we, in statistics, kind of 5% are kind of our golden rule, right? Anything that's less than 5% is considered unusual. So we're going to say anything that we have 95% is going to be, considered usual. If 5% is unusual, then 95% is unusual. Or excuse me, if 5% is unusual, then 95% is usual. So what does that mean? If you remember the 68, 95, 99, 7 rule, remember that 95% is about 2 standard deviations. So that's what we're going to do. We're going to do 2 standard deviations above the mean. And if I find 2 standard deviations above the mean, we're going to consider that unusual because that means 95% is going to be contained within the mean. So we're going to say 2% above, 2 standard deviations above the mean is considered unusual. So the mean, remember, is going to be what we have p hat, and then we're going to be plus 2 standard deviations. And standard deviation, remember, for this one is p hat, q hat. Q hat is 1 minus p. Let me just write it out the way you're used to seeing it, 1 minus p hat. Sometimes I write q hat. It just means 1 minus p hat. So we say, okay, we'll back up here. What's p hat? What's 0.2? So I say 0.2 plus 2 times square root of 0.2, 0.8 over 120. And that, I'm going to just go over here and look at my answer key so I don't have to do the math on it real quick. And that is equal to this one here. So we have... there we go. There's my 0.03 is this. and then 0.2. So 0.2 plus 0.03, which to have two standard errors above the expected average is about 27%. So, because 2 times that. So it's got about 27%. So anything above 20% is considered unusual, about 0.27. And of course, depending on where you're on, because it might be 0.28. Okay, so let's go ahead and jump to here. So I'm just going to explain these differences. Again, on this, on the answer key, the ones that I'm looking for is your random condition. And did you notice, see, it's not chosen randomly, but I assume they were because they're rangers and they're looking for a good representation of the population. And then this was my success failure. So these are the ones that we're having to do, the ones that I'm holding you accountable for. The other ones are definitely conditions that we use, but these are the ones that we're using that I'm holding you accountable for. Okay, let's look at what all of these definitions are. Let's just number them. I think it'll be easier. Okay, so confidence interval you can see is down here. Confidence interval just is, it's here and here in 2 spots. You would just have to label it in 1 spot for the test. Statistic, so remember a statistic is taken from the data. So that's just my actual numbers, that's the 91 out of 252. Let's follow the sample. So sample is this one here, that's the population taken from it's a set of data taken from my population. Parameter the parameter is not a number, it's who I'm studying. All right. The margin of error, remember the margin of error, how do you get that? Is here, and it tells you to be able to get the margin of error, it says that I'm going to, it says multiplied by 2 and get this. And the way I'm able to do that is this is the Z star times P hat 1 minus P hat over N. And so you can see the way it is described here, margin of error, the way it's described is this here. And the margin of error, remember, that's the plus or minus stuff. That's when you guessed my weight, when I said, oh, I guessed you're 140 pounds or whatever, and then plus or minus that 10 pounds. So it would be 130 to 150 would be your actual guess because the margin of error of 10 above, 10 below. Standard error, the standard error is actually this part here of that I am calculating, which I have shown in the work in this part here. So that's my number 6. And the assumptions and conditions. So it shows you this is my assumptions and conditions of my random sample and my large sample, which are the 2 things that I'm having you be accountable for. Okay, so when this next one asks you to interpret the confidence interval, guys, we've done this a bunch of times. I'm 95% confident the true proportion of hotels in the United States having a report is between 4 and 11% because I have 4 and 11%. So you're just going to lift this directly from the actual context of the problem. This one says a hospitality organization had reported that only 5% of hotels have experienced problems with bed bugs. Does this mean they have compelling evidence that the true proportion is really higher? Well, no, I don't, because I have 4% to 11%, right? That's what I got in here from that. And 5% is right in here. So what I'm saying is it's really likely to have 5%. Now, remember, sampling variability, if I ask you to go ask a bunch of hotels, you might get something a little higher. Or I ask your friend, you might get something a little lower. That's why it's a little higher and a little lower than 5%. That's my confidence interval. But 5% being inside this interval is very plausible. It's very, very likely that I could have 5% in there. And the way to have a smaller margin of error, look here, is to have a lower level of confidence. And that means is kind of, let's say I ask you to hit this target. If I ask you to hit this target, let's say you're there, yeah. I'm 90% confident that I'm going to hit the target. But then if I said, okay, now I want you to hit this spot on the target, now maybe you're only 70% confident. When I decrease, and so you have less margin of error to touch. When I decrease your confidence level, you decrease the margin of error. But if I increase the sample size, I'm going to also decrease the margin of error. The reason being is, remember, if you look at part of the formula, p hat, 1 minus p hat divided by n, and this here, remember, is the margin of error. This is the margin of error formula. Well, if I divide by a larger sample size, this number is going to become smaller. Just like if I tell you have one candy bar, you have to share it with 2 friends, versus one candy bar you have to share it with 3 friends. This one is definitely going to be smaller. Okay, this one here is just having you go ahead and walk through a problem. So this says I have drivers during a red light ran 43 out of 240 times. That's your p hat. And then the p, the parameter, as I told you, it's just going to be in words what you're studying. And then the standard error is just going to be this formula, p hat, q hat, which q hat, by the way, remember, is just 1 minus p hat. And then over n, and my n, it showed me is right here. Conditions, the 2 conditions that I'm holding you accountable for is my randomization, and it was done randomly, and my success failure, which is the large enough sample. You have to check your NP and your NQ, which remember Q is 1 minus p hat. It's the same thing. Remember. It's just another way of saying it. Sampling variability, just do your standard error, just find that. And then the 95% confidence, remember the confidence interval is p hat plus or minus z star p hat 1 minus p hat over n. And remember, to get z star, it's going to be inverse normal, which is menu, stat, distribution, inverse norm. The area, remember, is going to be in a decimal, but it's going to be the confidence level plus the tail. The mean is 0 and the standard deviation is 1, because what I'm doing is I'm on a normal model where the mean is 0 and the standard deviation is 1. This is a z-score that I'm looking for. And if I'm looking for a 95%, 95%'s right about here. This is 95%. I'm looking for this value right here, though. And my calculator starts here. So I've shifted over this little empty space. I have to include this little empty space of 2.5%. I know that's 2.5% because 2.5% plus 2.5% plus 95 is equal to 100. So this here I'm going to put in my area as 0.975 because it's 97.5% and the decimal is 0.975. Okay, I hope that helps. I think that's it. Yep, that's all we got. So do well on the test and then study hard. And take good notes.